Is this? Okay, so let's start what we call the derivative. So don't have to write these things. Let's see. Let me share the screen. Okay. Okay, have you screened the textbook already? Okay, all right, so that's okay. So this is derivative. So given the functions, derivative is another function called f prime, okay, whose value is this one, exactly this limit. Okay, so this is called the differentiable at x, and this is a derivative. Okay, so just a few example computing this limit. Find f prime 4. F prime 4 is this, how you compute this. Plug in 4 plus h, okay, minus f of 4 divided by h. Okay, so you get something. This is power 3 plugged in x plus h. Get something. Okay. And if it's just 1 over x, okay, so plug in x plus h here. So 1 x h divide, subtract 1 over x. Let's simplify this one first. Common denominator, x plus h times x. Okay, so you get x minus this one. This becomes 1 over h. And simplify, what you get this ones, cancel h. So you get this one. So you have negative 1 over x squared. So that's derivative of 1 over x. Okay, 0. Square root. The square root. Okay, so let's see. This is the trick. So let's do this in more detail. Okay. Derivative. Let's see computations. F of x equals square root of x. That's okay. So let's compute this one. F prime of x is this limit. So x plus h. Let's do long computations. This limit. X plus h, so that's square root of x plus h. Okay. And this trick, use this trick, so you multiply by, so we're looking for not replacing, eliminate the square root. So let's eliminate square root by multiply by the conjugate. What's conjugate? Is plus, and basically you multiply this by 1, so it won't change anything. And this now just like a minus p times a plus p. So you have square of the square root, so it becomes a x plus h minus x divides by, there you have still quite a few things, All right, so this cancel, x cancel, h cancel with this h. Right, so what you have is this. Okay, and this is exactly what you call the easy case when you just plug in h equals 0, that you get here becomes 2, right? Okay, so this derivative. In fact, let's do some computations. You may recall this binomial. If you have, looks like this one, you can always factor the x minus 1, sorry, x minus a out. And what's left is this one, x to the n minus 1 plus c, okay, x minus 2 a x minus 3a squared. What's interesting is that if you look at the power, this is power 1. This is a to the 0. If you sum up the power, n minus 1 plus 0, n minus 2 plus 1, n minus 3 plus 2, this always gives you n minus 1. You can guess this is minus, sorry, x minus 4, a. So the power of x going down, power of a going up. So in the end, you have, say, this is power x, a, and at the end, you have a power n plus 1. Okay? So this is what we call binomial formula. Let's compute again the let's see. This equivalent of derivative. Okay, so you can compute this way. Sorry. Yeah. This is the original. Okay. And you can also write something like this. Okay, so how you see this one? Okay, so get from here, from there, y equal x plus h. Okay, so you're replacing x plus h by y. Okay, if you replace x by y, then you see that if h going to 0, then you see y going to x. Okay, so you see from here also h is y minus x. Okay, they are the same. This is how you compute the a derivative using this limit, first limit, or the second one. Okay, so one example. What if m, and here is, say, let's start from okay, so first n equals 0. N equals 0, then fx is constant. Say c constant. Derivative c minus c over h. So because the top is always 0, this is absolutely 0. It's not something small, but 0. So you get, okay. Again, this is not okay because the top is absolutely 0. It's not going to 0. Okay. N equals 1, for example. Then you have something like this. X plus h minus x over h. Cancel the x. H divided by h, just 1. So that's the derivative. Okay, let's do some in general. And bigger than 1. Okay. So what we compute here is that okay. So this limit, I'm using the second definition. Okay. So f of y plus f of x divided by 1 minus x. Okay. So what we have here is that this is y to the n and by binomial, use binomial, factor this out. Okay, so what's left is square dot say y square x n minus 2 or minus 3 plus y x n minus 2, and then at the end you have x to n minus 1. Okay, there. So this cancel. Okay, so what you have here, okay, what you have here is just a polynomial, and this polynomial you just substitute y for x. So what you have is that this. How many is this? Got x. So this is x to the, okay. Here you have also, this is x, this is x n to the 2, so x n minus 1. So here you have also x minus 1. Here you have okay. So what's left is, well, how many terms are there? So you see, look at this one here. We start from there. Okay. And look at the power of x. In the end, what you have is you would like to have here. So you're computing 0, 1. I missed this 2. Okay, 2, 3, etc. until x minus 1. So how many terms are there? All right, so just count this one. How many terms is here? Okay, so this one comes from there, right? There. Here's comes from, that's the second one. That's the third one. Okay, so you just count how many terms in here. So from 0, 1, 2, 3, 4, whatever there, until n minus 1. So how many terms are there in here? This going to next one. 1, 2, 3, and then what?
Is it n terms, sir?
Is it n? Yes, it's n because we start from 0, right? We end up with n minus 1. So it is n terms. So what I call is that here you have n minus 1. So this is the formula that you recognize from that you use from high school. You would take a polynomial and then just multiply this out by the power, and then the power reduced by 1. Okay. All right. So let's compute this one. Equivalent derivative. So this equivalent limit. Okay, compute. Now this is what I thought earlier. Differentiability implies continuity. Okay. Why is it so? Because so I should, okay, that differentiability implies preferred writing. Okay, so f be differentiable. And so that means this limit exists. Let's see, plus h. Oh, h, this is h. This limit exists. Right. So let's multiply this out by Let me rewrite this first. Multiply this out by, let's see, 1 actually. So top h over h. Okay. So then just 1 here. So what we do is canceling. Let's see. Let's see. We'll see. I made a mistake here. Okay. And, okay, forget. This is what we need to show. Okay, I just we just follow this one. Okay, so what we need to show is that this limit, this is continuity, means that the values around C limit match with the values at C. Behavior around C, behavior at C equals. Okay, so let's rewrite fx minus fc this way. So basically writing this one equals x minus there. Okay, so this is similar to them what I wrote actually there. This is 1. Okay, and just take the limit here. Okay, when you take the limit, now because this limit exists, this limit exists, this limit exists because it's a constant, this is limit, also this exists, then you can just define the limit here, because limit, apply each limit here to this. And because this is derivative, f prime of c, this limit 0, they just see. Right, so this implies continuity. Okay, let's do multiplications. And not differentiable at corners and vertical tangent. It's not continuous. So 3 cases not differentiable is not continuous, corners, and vertical tangent. Okay. So let's see the sign for derivative. What does it tell you? Signs of derivative. Okay. So suppose we have, this is positive. Okay. What does it tell you? This is this limit. H minus f of, so it's A. Okay. Let's see 2 cases. H positive. When H is positive, right. Okay. This is positive. This is positive. So that's So then numerator should be positive too. Okay. Or when h is negative, so this is negative. To make it positive, then the numerator should be negative too. All right, but in this case, what does it mean this is positive? This should be bigger than this one. Okay, in here, in this case, but here's h negative, so this is actually less than a. This is bigger than a. Okay, so that means let's see, from these positions, a actually this is h negative, a plus h positive. Okay, so if f of a is here, h of a is okay, for every h, so that means the function looks like this one. Okay, so that means around a, sorry, I should write f is increasing. Okay, so similarly, if f prime is negative, that means around a, f is decreasing. Okay, so that's what the sign of derivative tells you. Okay, and let's do some more textbook. Like this notation, we'll do this later. Graph of derivatives. So that's graph of derivative. Okay. Derivative is zero. That means the slope of tangent zero means that the tangent are horizontal. Sorry. Yeah, that's horizontal. Okay. So if you, from this picture, try to figure out the sign of derivative, what you can tell is that here. Okay. So this is the sign for the derivative. All right. Here, because they at 2, the tangent are horizontal. So this is 0 here. This is 0 also here. Okay. Probably at 0. And because this is increasing, so then the derivative is positive. Okay. And between 0 and 2, the graph is decreasing, so the sign will be negative. Because this is increasing, the derivative is positive. Okay, so this is what I call the sign chart. Sign chart of f prime. Okay, so this is what it tells you. So positive slope, negative slope, positive slope. Okay. So then now the problems, let's see. Okay, so based on, let me just talk about this problem last 64. Okay, can you see already the graph? So we have two graphs, the solid blue and the dotted black. Okay, so it tells you that one is f, one is f prime, one is the derivative. So you gotta choose which is which. Okay, so how we deal with this kind of problems. Okay. So what we do here is that, let's see. Uh, Suppose we take this as a just trial error. Okay, let's do first this is f. Okay, so we try to determine the sign chart for f prime from this f. Okay. All right, so you see, this would value 0 here. Okay. Okay, so let's see. Since this is decreasing to the left of whatever the 1, to the left of 1, so here must be negative. Okay. And here, because this is all increasing, it should be positive. Okay, so let's try to match with this with the behavior of the dotted black graph. Okay, for the dotted black, is this correct? Negative means below the x-axis. Positive means above the x-axis. See that here? Now this is x-axis. Everything is above the x-axis. Okay, so this cannot be true. All right, you see the reason? So if we take this rule, some part of the the black one should be below the x-axis because this is negative. Okay, so and some part to the left to the right of one should be above the x-axis. Okay, but this doesn't match the behavior of f. Okay. Are you with me?
Yes, sir.
Yes, sir.
Okay. Yeah. All right. So then that's not good. So let's switch the behavior. Okay. All right. So because this is recorded, so I don't have to worry about. Let's erase this. Right. So let's take let's change to green. So let's take the dotted black as f. Okay. Let's find the sign chart for the f prime. Sorry, green one. Okay. Here's that 0. So it changes sign. Okay. To the right of this 2, it should be positive because it's increasing. And let's see. Right? And seems like it changed behavior here. Okay. So here's decreasing from whatever the number here, the 2. So that's negative derivative. And here, because this little part here is increasing, so this sign for derivative is positive. Right? So we try to match up with the blue one. So the blue one says that, well, to the right of 2 should be above the x-axis, should be below the x-axis between this and 2, whatever number here, this small number, probably 1/4 or something, and positive again. Okay, so above x-axis, below x-axis, above. You'll see, does it really match with the blue one? All right, so this is positive, this part, this is negative, positive. Okay. So that's matched with the blue one. So we can determine now, the black one is the function, the blue one is the derivative. Okay, so based on trial error, you can do the same thing with this 65. So if when you have a 3 now of functions, its derivative, and again derivative of that derivative, we call second derivative. Okay, so just pick one, say it is f, and then observe for the derivative. Again, what's important here is the sign chart. Okay. So let's see. So we have covered a little bit about 2.3, but we almost covered this 2.2. All right, so let's continue this next week. Okay, any questions?
Sir, I have a question.
Sure. Go ahead.
So for questions like these, is trial and error the only way, or is there another way?
You don't have formulas for this. The only tools is sign chart. But in order to use sign chart, you got to pick something, and then you have to start. So basically, it's trial error.
Okay, thank you, sir.
Okay. And the thing is, with this kind of problems, I like this kind of problems. No computation needed, right? So no calculator. You don't have to compute anything. Just observe the graph. Okay. All right, your questions.
So the sign chart is based on the direction of the tangent line?
Yes.
Okay.
Whether it's going down or going up.
Okay, sir.
Sign charts depend. Sign charts of what? If it is sign chart of derivative, then it's going based on going up and down. But sign chart for the function is that's a positive, negative of function. That tells you above or below x-axis, right? Functions positive above x-axis, negative below x-axis. Derivative positive, it is increasing. Derivatives negatives is decreasing. Okay, let's we'll have that later on. More questions?
Sir, I have a question about the absence in 6. Is it not open yet, or is there an error?
It is open. I opened it just before our class, actually. I opened it until 9:30, supposedly. Let me check.
Because it's not open here.
Excuse me, sir. In my screen, the CX math is not open yet, I think.
Not open yet? Let's see. Try it again.
Yeah, it's available now. Yep.
Available? Okay, so it's until 9:30.
Okay.
All right.
Okay, sir.
Okay.
Oh, it's available, sir.
All right, so I'll see you then next week. Okay, thank you.
Okay, sir. Thank you.
Okay.
Thank you, sir.
Thank you so much.
Take care.
Thank you,
Yeah.
sir. Have a great day, sir.
Okay.
See you next time.
Thank you, sir.